Hi everyone, we're going to continue our talk about angles today. Last time we talked about angle relationships. Today we're going to talk about how we can use those angle relationships to find missing angles. Alright, so one of those relationships that we talked about was adjacent angles. So one of the key things that we're going to look at today is if we have two angles that are adjacent to each other, like these, that means they share a common side and a common vertex. Okay? If they're adjacent, we're always going to add. Okay? So then we have to figure out what is the actual angle relationship. Is it complementary or supplementary? Well, if they're complementary angles, then those two angles have to add up to 90 degrees. So to solve it, we're going to set up our equation, solve for x, and then we're going to solve for the angle measurement that they ask for. Alright, so let's come down and check this out. Let's ignore these little lines that I've put in here. Oops. Alright, so here I have two angles. They're adjacent, so I know I'm going to add them together. Right? Now I have to decide, are they complementary or supplementary? Well, this little box in the corner tells me they are complementary. So these two angles are going to add together to equal 90 degrees. So 6x plus 10 plus 26 is going to equal 90. Alright, so let's go ahead and solve. So we're going to go back to our equation solving skills from a few units ago. We're going to start by combining like terms. Now I can go ahead and isolate my x term by subtracting that 36 from both sides. And when I do that, those 36's cancel out. And we're left with 6x equals 54. Now I'm going to divide both sides by 6. When I do that, my 6's cancel out, and we are left with 9. So now we know that x by itself has a value of 9. But now we need to figure out what the actual angle A equals. So we know angle A has a value of 6x plus 10. And if I know that x has a value of 9, I can substitute that 9 in for x and work out this problem. So we find that angle A has an actual measurement of 64 degrees. Make sure that you are putting in your little degree symbol. Okay? That's just like labeling your answer with a unit of measure. We have to put that degree symbol there. All right, let's go ahead and try this one here. So here I have two more angles. Okay? They're adjacent, so I know I'm going to have to add them together. Now I need to figure out what will they equal. So these two angles together form a 90-degree corner. I know that because they told me that this corner is 90 degrees. Well, if this corner and this corner together make that nice straight line, then I know that this one here must also equal 90 degrees. So I'm going to add my 7x and my 8x because adjacent means add, and this time they're going to add up to 90 degrees. I'm going to combine my like terms. I'm going to divide both sides by 15, and then I'm going to find that x has a value of 6. Alright, so now to find the measure of angle M, okay, that's just 7 times x. So 7 times 6 is 42, so the measure of angle M is 42 degrees. The measure of angle N is going to be 8 times 6, so the measure of angle N is 48 degrees. All right, these are going to be some problems for you to try on your own, but first let's take a look at the next example. Alright, so again, adjacent, add. Right. Two angles are adjacent to each other, we add. So first thing we want to do is identify that angle relationship. In this case, we're going to talk about supplementary angles. Supplementary angles make that straight line, and they add up to 180 degrees. So we set up our equation, solve for x, and then we solve for the angle measurement. So let's take a look at these two examples. So here I have a straight line formed by these two angles. These two angles are adjacent, they share a side and have a common vertex. So these two angles here are going to add up to 180 degrees. So I'm going to take that 5x plus 22 and that 98 and I'm going to add them together and set them equal to 180. Now I can combine my like terms. I can isolate my x term by subtracting 120 from both sides. Then I can go ahead and divide both sides by 5, and we find that x has a value of 12. So now if I want to figure out what the actual value of angle Z is, I'm going to replace that x there with 12, work this problem out, and we find that the measure of angle Z is 82 degrees. All right, let's try one more just like that. So here, once again, I've got this straight line formed by angle R and angle S. These two angles are adjacent, so I'm going to add. Adjacent, add. All right, they make that straight line, so they're supplementary, which means they're going to add up to 180 degrees. So I'm going to take that 9x minus 10, and I'm going to add it to the x plus 20. So 9x minus 10 plus x plus 20. I'm going to go ahead and combine my like terms. So the 9x plus x gave me 10x. The negative 10 plus 20 gives me a positive 10. I'm going to isolate my x term by subtracting 10 from both sides. Then I'm going to divide both sides by 10. And we find that x has a value of 17. Now, to find the actual measurements for R and S, to find R, I'm going to take that 17, substitute it in for x. Work out the problem, and we get 143 degrees. And then to find the measure of angle S, I'm going to do the same thing. Substitute that 17 in for x, work out the problem, and we end up with 37 degrees. As a quick check, I can add those two together, and they should add up to 180 degrees. You've got two try on your own problems here, but first let's go over here and take a look at our last type of problem. Okay, so this time vertical angles. Vertical angles, if you remember, are across from each other. All right, so they're not adjacent, so we do not add these two together. We only add if they are adjacent angles. So if we remember, vertical angles are equal to each other. So this angle is equal to this angle. So we identify that angle relationship. In this case, they're vertical, so I know they're going to be equal to each other. We're going to set up an equation, solve for x, solve for the angle measurement. So I know that x plus 16 has to be equal to 4x minus 5. So now I can solve. Right? If you want, you can draw that line. Right? I'm going to get my 4x over here, so I'm going to subtract 4x from this side, subtract 4x from this side to get my x's together on one side. When I do that, I have negative 3x plus 16. These guys here cancel out, and I'm left with, I lost my equal sign, negative 5 on this side. Now, to isolate my x term, I can add subtract 16 from both sides. When I do that, I'm left with negative 3x is equal to negative 21. Right, now I can divide both sides by negative 3, and we finally get down to x equals a positive 7. So now we know what x is. So now we want to figure out, well, what do these two angles equal? We know they're equal to each other, so we only have to work out one of them. Right, so to do that, I'm going to just use this one here, the 4x minus 5. So my x was 7. So 4 times 7 was 28, subtract 5 from that, and I get 23 degrees. And we could do the same thing over here. I could take that 7, plug it in here, add it to 16, and we should still get 23 degrees. All right, you have 1 or 2 more try on your own. When you come into next class, those answers will be provided for you. So make sure you complete those 6 try on your own before you come to class. I will see you later.